You are the founder of Commonware, Patrick O'Grady, and you were previously running integrations at Coinbase, sort of connecting all these different protocols. And then afterwards, working at Ava Labs, being the VP of engineering. And you realized that sort of abstractions are great, but advanced developers sort of have to work around them. They're sort of hurting advanced developers who want to do new things. And so Commonware is trying to not be sort of a framework, but more of a library for developers to do whatever they want. Is that a good rundown?
Yeah, I think in a nutshell, a long time ago, maybe 10 or so years ago now, Bitcoin obviously inspired a lot of other people to try and decentralize and like disintermediate different sorts of applications. But rebuilding everything from scratch every time was obviously not the most efficient approach to the problem. And so solutions, or basically people took this approach, were like, what if we created a framework to make it easier to create like Bitcoin or blockchain like looking things, whether that be deploying smart contracts or something like the Cosmos SDK with Tendermint. But I think a lot of people forget that that was just an abstraction decision at that time, and it's not like a law or a rule or something that we have to do. And as we have evolved into like higher performance and more specialized applications, just like any time when you have like, if you're building websites using like a website builder versus like building something from scratch, there are limits you run into that when you want to unlock that next level capability or next level performance, that you just eventually need to do more yourself or like do more that's specialized to your application. But in the space today, there are few, if any, you know, things that help you do that in a reasonable way. It's really like framework or nothing. And I think there's a lot that's lost in the middle between those two. And we think that the right approach for the next 10 years is a more careful balance between like having this library of like sorts of capabilities you can tap into, but it's not so restrictive in that you like must be a framework or it must look a specific way. So yeah, that's the idea with Commonware, and yeah, we're about 6 months old now, so just keeping on.
So you guys aren't exactly sort of against frameworks or abstractions. Like they're still helpful, but for sort of the next level of
Mm-hmm.
infrastructure, sort of a lot of people tend to just write everything from scratch, which leaves a giant, I guess, gap. Is that called a library? What sort of is that gap referring to?
Yeah, so we're definitely not against frameworks, and like we're not calling like virtual machines no longer. If you're doing that, like you have no idea what you're doing. I think there's like this gradation of development. The joke I told at one point is like I think of Commonware almost as like the like pro mode for like people trying to build stuff, where it's definitely not the first thing you're going to probably pull out when you're building something if you've never built in blockchain before, because a lot of the concepts are probably pretty foreign to you. I think over time we hope to like improve the developer experience such that maybe that's possible, but in the short and medium term, it's definitely for people that have been in blockchain and crypto before. They know what these things are and they're frustrated with what is currently available. In terms of like I think like, is this a library, is this a framework, is this whatever? um, yeah, we at least with Commonware, our open source thing we call the Commonware library, and it's a collection of a bunch of different primitives that and these primitives are typically like commonly useful things that if you're building your own blockchain. Now, why not build everything from scratch? Folks that are in the space know that crypto moves super, super fast. Like if you set a goal to like tackle one application, if you build from scratch, by the time you get there, you may have missed your window. Like let's say that I was today like targeting stable coins because Bridge got acquired and everyone's super stoked about it. And you're like, I'm going to build the perfect thing from scratch for stable coins. If it really is the perfect thing and has like a bunch of sophistication, like you're probably time to market is like a year or two maybe. Whereas if you lean on the like shoulders or like a set of things that already exist, you could greatly reduce that, but maybe not quite as good. We think that if you have like this set of commonly useful things, that maybe for your application you only need to customize half of it, that you can greatly expedite your time to market, and then over time potentially replace those lower level components if you're using a stack or like library that's meant to have things swapped out. So it's not to say that you should always build everything from scratch. If you're capable of that and you like really need to do that, great. But what we have seen is people want more of a balance, rather than this like black and white of like building on your own or building within a very specific sort of way. Yeah, and how that's possible is, I think the best way to describe it actually would just be kind of like taste. Like you a lot of people are like, well, how is that possible, or how do you think about making that capable? And it's really just trying to avoid like a monolithic interface at any point, and then making sure that you have incredible testing capability to ensure everything stays reliable. Because usually the problem people quickly will equate something like this to microservices, and then people then are like, oh, microservices like that died out a few years ago because it drove everyone insane. And I think when you introduce such deep customization, thinking about how to really reliably keep it running and maintainable is usually the first problem you run into. And so we're designing everything with that in mind, and hopefully we can balance that customization with ensuring things stay reliable.
Mm-hmm. For abstractions, they typically have these interfaces where sort of you don't have to like make everything yourself, but you still have to plug in a couple of wires. Sort of how would you sort of build with Commonware if there isn't sort of any abstractions? Is it sort of like typical stacks, or like you work from the bottom up? Sort of how can people think about building with Commonware?
Yeah, so that's exactly it. So the way that we think about primitives is, we design a minimal interface, like basically a minimal integration point with shared types. So that's probably the simplest way to explain it. So, for example, um, in the P2P layer, which we expose, we try to keep the interaction point as streamlined as possible. So what you provide to P2P is basically, I want to send bytes to this public key. That's it. So there's no like crazy customization you do within the interface itself. All of that is defined based on what you actually import as a primitive. So the idea is that we control the complexity that matters by like having the like commonly exposed integration point to an application be super small with a set of shared types, but then have everything related to like what makes that P2P primitive unique live outside of that really small, like maintainable interface. So, but the way you pull it together, yeah, it's like we have a few examples actually in the website. So there's three that we currently have. One is like a chat application. So it uses the P2P to have encrypted chat. The next one is a VRF. So it uses threshold signatures to perform basically a threshold signature over like rounds. And then that signature itself is a source for a VRF. And then the last one is this consensus log. And so they proceed in increasing complexity. So like the chat one is just like a P2P primitive, which has like the ability to connect to different peers and discover them. The VRF has some cryptography stuff coupled with the P2P. And then the consensus has the cryptography stuff, the P2P stuff, storage, and then consensus. So you can see how you can like stitch these things together. But in practice, what it ends up looking is like, yeah, instead of having this like single layer, it looks more like a vertical thing where you can basically have like different connection points more on this pole rather than kind of like a level surface. And like I said, it's not like the right fit for like the beginner here. It's more for people that say like, oh yeah, I'm building a interesting exchange, and I need a lot more logic in the mempool layer. So I need to replace or like really have a very specific handling around how P2P interacts with like my pre-consensus information. And so right now you could fork things to do that, but generally it's not easy to do if your interface layer is like this, because you end up trusting the developers to like build something that's good enough across a bunch of different application dimensions. And unfortunately, I think the abstraction boundary to do that is just really hard. Like you can try to do things like Cosmos did with vote extensions, which was a really cool way to like add additional logic into like how vote messages are passed around. But you end up having to play that, use that playbook all over the stack, and it quickly becomes difficult to like there are so many layers of abstractions at different points in time that sometimes it can just be easier to implement what you need. I think the downside of that is obviously how you actually get ecosystem compatibility and infrastructure standardization, because if everything looks super different, it's like like a O of one integration, or sorry, like an O of n integration problem, rather than like this O of one thing that is really useful if you have something like the Cosmos SDK. So it's not a risk-free trade-off. Like, you are making decisions here to improve the application experience, but people in 2025 now, I can say, that are building applications want to do something novel, or need to do something novel to actually break into the market in a meaningful way, where like just deploying another framework-based thing, whether that be a stack or Cosmos SDK or whatever, like I just don't think it hits the same way as it did the last few years.
Yeah, I want to talk about code bases, because a lot of Cosmos projects who like want to do ambitious things, they like use the SDK, and then they realize sort of years afterwards, like, it's kind of has all these problems and tech debt that sort of like, oh shit, we should have just like used Tendermint and then like done everything else. Can you talk about, like, I know Barachain went through this, Penumbra, Astria, sort of a lot of people like certain components, but then like will build everything else themselves.
Yeah, I mean, I think it's just like this alluring thing as you get in, right? It's like you want to get to the POC point. So you have to think, I think about it more as like how a business grows, or like how a project grows, right? You're trying to get to market as fast as you can, because that starts to give you like the ability to generate a compounding advantage. Now, what invariably happens is you're going to pick like what is probably one of the quicker things to get off the ground. And so you get started, and yeah, framework for sure, easiest way to get off the ground. Like, no doubt about it, right? Like, I think there's tons of examples online of how to spin up like a Cosmos chain in like a day that does a bunch of different things using all these modules. Like, that's super appealing for a lot of people. The problem ends up happening for at least advanced teams is once you get to that point, your actual like ability to make deep changes from then on, very difficult. But because you've already like gone to the quick launch path, you kind of get stuck on this trajectory where like the things that got you to that quick launch are the same things that make it really difficult to like deeply modify things, because you start to have to break away all those like acceleration, design capabilities, or like design rules that like actually got you to that point. And so I think you just get on this track where it's like, I need a launch, I get on the launch, great, and now I get stuck because like that one thing I need to change is actually like 5 layers deep into the framework, and so I need to start forking. And then once you start forking, it's just a super slippery slope of like engineering waste and time of like actually trying to keep it alive. And so I think there's this whole world of people that view like what modern blockchain deployment is like a new version of AWS, or like a new version of a stack where like it's just a database. You keep the database is behind the application, and you just need to like deploy this new type of database, whether that be like some sort of standardized rollup infrastructure or standardized whatever. And then from there, the actual like sophistication is the application layer above. I don't view, I guess, blockchain development that way, and I think it's not a database. Like, I think there's a lot of logic and complexity that can be injected into those lower layers. And so that approach of just trying to like get things up and then build on top, I think it leaves a lot to be desired. But yeah, from all the conversations I've had with different folks, it's really this balance of everyone's a startup. So you're just trying to get off the ground. But then by the time you get off the ground and launch something, you realize migrating live state post-launch is one of the hardest things you can do. And so you've locked yourself into a certain path. And so similarly with the testing that I talked about earlier, the ability to test extensively deep changes to the code base is super important if you want to continue optimizing and move fast. And so if the entire code base is not designed for that sort of testing, you end up just, it feels like you're walking in the dark a bit with a flashlight. Like, you change this thing, and if you don't know how to actually test it or how it like interacts with previous versions of like mechanisms you've deployed, usually that ends with an outage, unfortunately. And so you need to be very careful with how you actually think about rolling out those changes to live networks, especially when there's a lot of live state involved. So I think in a nutshell, we have tried to cast a developer experience from different industries onto the way to build blockchains. And I just don't think, I think for like the expert developers or like the best developers, that it's just not the right framing to actually move quickly and not break things ideally.
Can you talk about sort of languages? There's always this meme of like, you know what, like I'm just gonna, I hate microservices, I hate this stuff, like I'm just gonna resimplify everything and write it all in Rust. And like projects have done that. Could you just talk about the languages with Commonware? Is there any problems? Or are people gonna say, hey, this is all Rust, I want to write in Go? Can you just talk about that?
Yeah, I mean, so my experience is very Golang heavy. So my entire time at Coinbase and my entire time at Avalanche, I worked in Golang primarily. Hilariously, when I was actually at Coinbase, like there was one or two times where I got like work assigned to me, and it was like touching some Ruby code or something like that. And I would purposely go a little slow because I was like, I don't really want to become the Ruby guy here. Like, I really don't enjoy Ruby. And so Golang was my exit. And for people coming from Python or like something like that, to me, it's just like a better Python. It's a great thing to use. And I enjoyed writing in it for many years. Now, Golang is really good up to a point. And eventually you get to this point where when you want to optimize further, you need to basically write code, compile it, see how like Golang actually turns it into machine code, and then make very subtle tweaks to get it to be faster. So like whether that's passing certain things by reference or not, or like changing the order of different operations, Golang tries to be smarter than you, and it doesn't give you direct control into how certain things are actually end up being compiled. Even if you think you're passing something by reference, like Golang may say, no, you don't need to do that. And so you end up, when you get to like the higher performance world, which is what I was working on in the Hyper SDK at Avalanche, you end up having to get really deep into like working around the compiler. So, and you end up writing code that doesn't look like Golang anymore. It looks kind of looks weird, but it's fastest. Rust, you don't have that problem. Like Rust does optimal, like will optimize stuff in the compiler in the same way. But if you tell it to pass certain things by like memory a certain way or like do certain things, it will do that. There's no like weird like compilation, check machine code, compile, check like that you have to do. And so when you actually want to tap into higher performance, it ends up being a great step. Now, the other reason why Rust is super useful and popular, so just for some context, I haven't talked to anybody in the last 6 months that's building something really new and powerful that's using Golang. It's almost entirely Rust or something else. And at least in the case with Rust, the cool thing you get is like all the ZK work really assumes you writing in Rust, and then all the really cool cryptography stuff is written for Rust. And so in blockchain, both of those are like super popular concepts right now. And so if you use Golang, it's an uphill battle at best to like figure out how to do all that stuff. Particularly in Golang, you can't even. I'm not aware of any like any toolkits or like SDKs that let you like create ZK stuff. There's probably something, or or like turn it into WASM or whatever. Like everything seems to run through Rust at the moment. And so when I was picking what language to use for Commonware, it was pretty obvious based on the conversations I had with different folks, which was like, yeah, they definitely want and need Rust based on like the other stuff that they're building in their application. Now, again, I don't think of the Commonware library in the short and medium term as trying to like convert as many people as possible to use Commonware today. So like if it was in Rust, like I'm not so concerned about the person that says it has to be in Go, like I'm going to write it. It's like for your application, that might be better. You're the one to make that call. But for the folks I've been talking to that want to use like a lot of these newer capabilities, but like need more flexibility into how those things are actually like instantiated and deployed, Rust is pretty clear. And then the last thing actually relates back to testing. So in Golang, the runtime controls. So for people that are familiar with Golang, when you spawn like a concurrent task, you spawn some sort of Go routine, and then you trust Golang to basically handle scheduling of Go routines. Some people say that's super convenient, and like the whole point of Golang is it's like I think it's called like fearless concurrency or something like that, where it's super easy to just like write a lot of concurrent code with channels and Go routines. And I agree, it's super nice. The problem is that if you want to do like really cool testing without emulating the kernel or like writing your own like virtual machine hypervisor or something like that, you can't, because you need to be able to control like the order of execution of async tasks. In Rust, people complain about async Rust because it's like you have to have your own executor. So people use Tokyo, people use all this stuff, but they fail to typically like talk about the door that opens. So like in Commonware, we have this like deterministic simulation engine, which is our own implementation of like a async task scheduler, so that we can do really extensive simulation and testing of all these different things in a deterministic way, which is something we just couldn't do in many other languages. So in summary, cool stuff's written in Rust, not in Golang. And then it makes it a lot easier to test because of the way the Rust language lets you write concurrent code.
Yeah.
That was pretty. Hopefully, that wasn't too too.
No, that was good. There's been a lot of hype around Rust, and sort of like all the new things are all like, fuck it, I'm gonna write all in Rust. It's never I'm gonna write it in Go. Go is like it's like Java nowadays.
Yeah.
Sort of. It's great for like.
I will say one thing about Rust, which is like people always make this joke that like, or they say like Golang's so much easier to prototype in, like, oh, like, you know, if you write in Rust, like you better start in Golang and then you're gonna have to migrate it to Rust, whatever. I actually think that is wrong. I find it way easier to prototype in Rust, and the reason for this is that if you prototype like concurrent code in Golang, you're probably throwing like locks all over the place. You're not being super careful with how like you're accessing different variables. And almost all the time when you like compile that proof of concept and run it, it doesn't work. And so you end up spending just as much time debugging your like shitty proof of concept as running the proof of concept. Whereas in Rust, every time I've written a proof of concept, the first time it just works. Like I don't debug anything because it doesn't let you do super stupid stuff. So it makes you take a little bit longer on the build part, but I find that like the total time to actually get a proof of concept running is less. So I just want to make sure that I got that digression in there for the Golang skeptics. But
yes.
Yeah.
I feel like Golang is good for frameworks because it's like more simpler to program, and like if you sort of don't really care about the high performance stuff, but like all the high performance people, it's all Rust. They love sort of the how specific and safe it is. I want to get your sort of explanation of the name Commonware. What is Commonware? Can you like explain that it's not an L1? It's not going to take away your ecosystem and all that.
Yeah, coming back from the Golang versus Rust digression here. Yeah, so the idea with Commonware actually was born out of the name actually came out of some frustration. So I think a lot of people that work in the space see a lot of infighting all the time about like things that it just seems odd that there's so much infighting over. Like if you claim you have higher performance or like TPS, it turns into this battle between other people that claim they have the highest TPS for like some super specific optimization that only they have access to and that they wrote and they like published some paper about. Like anyone that's in the space and listens to podcasts like knows exactly what I'm talking about. And you know, when I was thinking about doing Commonware, it just was so frustrating to me that like if you published or talked about anything that was performance related and you were associated with an ecosystem, you got other ecosystems that just absolutely like came at you with all sorts of like, oh, you don't know what you're talking about. Like it's not whatever, it's anything. You name your reason. And for developers looking at the space from the outside in, we look crazy. Like that's just, I don't understand why. Yeah, we're just too like everything is so naive, like nascent and everything that like focusing on this sort of like idea that you own any particular innovation and that like it's just so fundamental to your project, to me just is obviously there's like monetary incentives for why you need to like assert dominance with this whole like token world that we live in, but it was really frustrating to me, and like I think it was a little demoralizing that seemed like the only way people could work on like different high performance things. And so with Commonware, I wanted to make sure that the name was locked in and reflective of what this is. We create stuff that we consider to be at like state of the art level performance, and we are just releasing open tech that you can employ. However, when you launch something, the whole reason for the name is that it's commonware. So it's more than just open software, like that it's permissionlessly licensed. It doesn't belong to any ecosystem or any like particular branding. So like when you launch something using Commonware, I'm not going to quote tweet you and say like only possible to use with Commonware, or like powered by Commonware, or like built on the shoulders of Commonware, because that's what every other ecosystem seems to think is a good idea. Instead, it's just code. You can brand it, you can use it however you want to. If you want to just copy the entire code base and change the name, like you're within your rights to do that. Like it's meant to just be useful stuff that if you're building in this space that would be useful to you. And so the name Commonware is really about making sure that ethos is clear from day one to day whatever. And hopefully we do better at that than OpenAI did with like the open AI research. But yeah, I think it's important that the space has this like neutral collection of like awesome technology that isn't so tightly associated with ecosystems, so that people feel like it's us versus you sort of thing. It's not. It's just like hopefully it helps anybody however they see just build cooler stuff, because that's really the goal here. It's not to beat your ecosystem. The goal is to compete against like what the traditional internet experience is. And I think sometimes we lose sight of that as an ecosystem or as an industry.
So there is no token. Can you talk about the business model?
Yeah, so all of our code is open, MIT Apache 2. Anything you can see, you can use however you want to. The idea for the business is that as we migrate to a higher throughput world of applications, it will no longer be tenable for people to run all of their own infrastructure. We're already seeing problems at like 10 TPS and 100 TPS. At like 1,000, 10,000 or more TPS, you can't just like run the node, like run an archival node and stick some like Cloudflare RPC over it. It'll be really expensive, really hard to keep stable, or it just simply won't work. Like you'll run into max size limits up for like an archival node on AWS, unless you like stripe hard drives. And like, I just think as we approach the end of the TPS era, I think we also approach the end of the era where like people can deploy all of their own infrastructure. And so Commonware is really meant to be not competing on the protocol layer, but instead trying to help augment the need, like the stacks that people build with really performant infrastructure stuff that we think that you're probably going to need. And it's not like running your code. We don't think that's the right interaction. Instead, we want to like build things that you could only build or like support as a cloud native thing, and then offer access to it. So think of it more like building something like an S3 or building something like a DynamoDB, not like running Postgres or something. And so we are aware of a few different types of products that would be super useful to like actually scaling a blockchain experience to a lot more people that we think are that fit super well into like the way the Commonware library works. And if they were available as like code, it would be really difficult to run or manage because it's inherently like this multi-region, multi-cluster sort of setup. But we think that in a world of high throughput blockchains, that developers that are just trying to build an awesome application are going to have a whole new set of problems that are much more difficult and much more expensive to solve and can't be like bandaged over with just running the node behind something. And so we are focusing some of our development energy on like how we actually uh, make it scalable to interact and like scale participation in Commonware based stuff. And the primitive architecture makes it a lot easier to do that. So we can like swap out different primitives that are maybe functionally compatible with things that are backed not by like some local device capabilities, but by something that is more like a superscalar architecture. And we can't do that if everything is so tightly intertwined behind a framework.
Could you talk about how sort of these high performance systems look more like sort of Netflix running sort of all these nodes all across the world that are like efficient and they have like all these engineers versus like just running a server that like we sort of think about where it's like just run a chain and that's it. Can you talk about how it's more towards distributed systems than computers and servers?
Yeah, I mean, I think it's a little bit more complex because I think to me it's really that balance that I think is really front of mind right now in like the Ethereum versus Solana thing. If you want to run something at home and like you want to have tens of thousands of people that do that, you just need to design something very differently than if you want to assume like things are running in data centers around like servers that are really well connected to the internet. So I think a lot of the existing stuff that's out there today believes that you can't have like the blockchain ethos without this anyone can participate component. So like everything is designed that way, and if you're designing that way, you need to assume a lot of different things that are really like a anathema to getting high performance. So like it looks closer to like a traditional web server, but like for example, certain things, right? You can't assume that you're going to be connected to everybody. You need to hide like kind of your identity so you don't get DOSed because you don't have like all these crazy firewalls and like things to hide. You can't assume that it takes too long to verify anything because like you may get stuff later than other people, and if like the block production is like super tightly synchronized, you're just going to fall off, and a bunch of people will fall off. You need to make sure that you can recover. So like if you have the state being like tens of terabytes, like really difficult to like boot up a node for the first time or like join the network. And so I think a lot of the stuff that was built over the last 10 years is very much like geared to this. I think Solana, credit to them, like really offered like the first real different approach, which is to say like we can still build a decentralized network. It's still decentralization is such a relative term, but like still can have a lot of like open participation, but instead target a much different, like a much higher level of capability than like what we have typically seen. And if you do that, you change a ton of the design. And so what I think we see today is a lot of people using architectures meant for this like at home or like lower performance thing, and then trying to use it in this like high performance world. And it just ends up being a lot less performant. Like in that high performance world, you want to be directly connected to all the validators. That's just not something a lot of these other stacks do. Like for example, Tendermint doesn't assume you're connected to everybody or directly connected, or like take your staking identity and match it with your peer identity. Similarly, like it doesn't assume like any sort of reliable broadcast of transactions prior to consensus. It doesn't assume like you have this high performance CPU or like disk that can like be used, or a ton of RAM to like make sure that you can verify blocks at a certain speed. And so as you move into this world of super high performance, you just make a lot of different design decisions, and a lot of what I think is coming down the pipe for like new frameworks, new approaches are now building for this world, because it's really difficult to get super high throughput in this world unless you assume that you have some like super mega sequencer that produces ZK proofs, and then everyone else is just kind of a verifier. And that to me seems that decision that that group has taken for trying to achieve high performance, whereas the other group that's like trying to build these like super high performance clusters don't assume like you have like a single producer that everyone verifies, but still have everyone produce. And so it's interesting because I think 5 years ago, those sort of people would have said that's not decentralized because it requires this like super mega prover that can do all this stuff and has all the traffic run through it. And if that thing's shut down, like the whole thing's broken. So this almost now kind of looks like the more decentralized path because anyone can produce something and everyone verifies rather than a single producer with many verifiers. So it's becoming a very nuanced conversation where it almost feels like things have switched. But yeah, that could get pretty heated on Twitter, I think, amongst those groups. But in any case, if you assume more capability in hardware, you would design very different mechanisms. And so when you design those very different mechanisms, uh, they typically are inspired by like other high performance systems that operate online today, and those are all like from the like the big cloud providers or like the big internet providers because they know what it looks like to serve a lot of requests at scale. There's nuance to make it work in blockchain and like having deterministic execution and like how you still like make things syncable and like how you go from crash fault tolerant to Byzantine fault tolerant mechanisms. But that's what I've seen as the trajectory.
Could you talk around the primitives that sort of you guys are building at Commonware? Any examples, and then sort of like what can you like build with it?
Yeah, so the first thing we created was an authenticated P2P layer. So this is built from the ground up. So there's no like libp2p, there's no anything. It's just over direct TCP connections. So we have our own stream library. So like you basically connect or stream primitive. You connect to someone, authenticate that connection, and then we have a P2P layer that sits on top of that that does like peer discovery and like keeps the cluster. It's like basically the P2P network in sync. The reason why we did this is it actually follows what I was just saying, which is most of the P2P constructions today. Two things: they don't assume you want to be fully connected to different peers, and then two, they assume you don't want to like connect the peer identity to the consensus identity. But if you do that, you get a bunch of different simplification. So we actually don't use TLS. We use our own handshake with a Cha-Cha-20 Poly 1305 stream cipher. And then actually you use your consensus key to perform the handshake on the P2P layer. Similarly, we can use that information to do really efficient discovery of different peers using bit vectors. So like the overhead for like the P2P network is laughably small. Like you send bit vectors of like, if it's 100 peers, it's 100 bits you're sending over the wire to let people know who you're connected to, compared to like traditional P2P networks where you're like kind of randomly gossiping, tons of different peer information to everybody else. It's dramatically lower overhead. And then not to mention, most of the advanced consensus and cryptography things assume you have like directed encrypted channels. So we have that. And so it's really powerful to build on top of. So on top of that, we have a cryptography layer, which implements a threshold, DKG, and then threshold signature construction using BLS 12381. This is super useful for doing all sorts of stuff, least of which is giving the consensus implementation a long-lived static public key that when anything is ever finalized produces a signature that can be verified against that static public key. So to be very specific, if I created a Commonware consensus instance, it would have a static public key. I could put that public key into an Ethereum contract, and then anytime a consensus decision was finalized on Commonware, I could take that signature and prove anything about the block against it on Ethereum. So if you wanted to like build like a cool like deposit withdrawal flow, super easy. If you wanted to have Commonware instances talk to each other, you just enshrine the key basically from consensus, and you assume that as long as the consensus on another like connection hasn't, or like a recipient hasn't been compromised, that anything that's signed by that consensus key can be used or proved against as like part of the canonical chain, which dramatically simplifies interop. And so we built the cryptography implementation to power consensus, and then released our first version of consensus, which is simplex the first simplex consensus implementation to actually run the DKG for threshold, and then are now working on the next consensus instance that actually uses the threshold signatures and produces threshold signatures. So what you can build today, like I said, we have like 3 examples to kind of show the breadth here. You don't have to use these things together. So like if you just want to use the P2P stuff for something, great. Like if you wanted to just to use it with like say like an AVS on Ethereum, you can use the validator public keys as the input of the AVS, and then you can just use that to build arbitrary like restaking applications without any other forks of anything. You just can connect the Ethereum validators next to each other. You can use like the cryptography to build like cool cryptography constructions unrelated to consensus. And then with consensus, you can obviously build like anything that relies on a replicated log. So if you wanted to take like Reth and like hook it up to this, you could do that. Or if you wanted to build your own execution environment, you could do that. The cool part is because the layer or like the different pieces are disconnected, it makes it super straightforward, at least to connect other networks if you're like more into the modular approach to launching things. And so I think when we launched like the Commonware stuff a few weeks ago, Nick was like, "This is the most modular approach ever attempted," or something like that. And that's really how people in the modular ecosystem should think about it. Like, if you want to, secure everything on yourself, you can. But if you also like want to rip out parts and put different parts in that are like secured by other components, it is possible to do that in a relatively straightforward way. Now, for Commonware, like we are super interested in helping people pull these primitives together to launch an application and or develop primitives that fit into the Commonware stack in a way. So like if you wanted to build something like an AVS like shim or like AVS primitive that lets you do that, we'd be super interested to collaborate, similar with Celestia and other sort of modular approaches to things.
For these applications, there sort of is a problem of the people who make the sort of library or framework and then sort of having like usage of that. And so there's the problem of sort of you have to like have a success story, and either you do that all yourself, you show the first example, but then you sort of lose on that like neutrality and now other people can't try out on that. Or there's the like, we're just going to build it and like hopefully they come. So like where is Commonware on that?
Yeah, that's a good question. I think in an ideal world, everyone like just builds something. They're like, it's so cool, like it's inevitable. People are gonna like rush to this thing, and like 99.9% of the time, that's definitely not the case. Some people will only build things like this if they have like a particular customer or like person building in mind that is like really desperately asking for it. Like I think at least in the case of like Malachite, they waited to work like Starkware came out to them to build like a decentralized sequencer, and that was like the push that got things started, and now they're working on that approach. I think so. We are talking to a number of really strong teams and that are interested in like deploying this thing, but invariably, like again, we're all kind of startups. So putting all your eggs in the basket of like another startup historically has not been like a high expected value move necessarily, unless you're very careful with who that person is. But so our approach is really twofold. So we're collaborating with different teams that really understand what we're doing and want to leverage Commonware to build whatever they need for their users, but then also evaluating different ways to bring like unique experiences to life that can showcase again like kind of like if what it would look like, or like so it's easier to say I want to replicate the success. Now that's super nuanced. Like in an ideal world, we don't have to bring anything to life. I think but it's difficult to put basically to give up your future as a startup to like other startups, I think exclusively. So I think it's important to hedge your risk, and we're using it more to like build out a lot of these other primitives that we think people will need, and make sure they're well tested and they're functional and they work well. So yeah, I think we're pretty interested in showcasing what's possible, but we aren't quite sure yet if we want to take that all the way to like a production launch as much as just like a really useful long-lived example for people to like understand what this system is capable of, and like build out a lot of those infrastructure capabilities so people can see how the whole story is told. Because in a lot of ways, like we're zigging where like a lot of people are zagging. Like, you know, we have this different type of stack. We have a different type of business model. There's a lot of new things going on here. And if it takes me, 45 minutes to an hour to explain to everyone exactly how it works, it can be difficult to help get the story started. So, but yeah, we're being very careful, because I think at the same time, we definitely don't want to come off as like this Apple comparison where they're known very much for like popular app. We could do that popular app too, and we think that that's a really destructive approach for someone that is like working on like SDKs as well as applications. And so we are not trying to like wait to see what people build and then just try to build a better version of that or something. That's something that we're very much keeping in mind as we like have these conversations with different folks.
Yeah. I think typically, like, you talked about Apple, you talked about OpenAI saying they're open, but then like not being open. I think it's more on actions. And so, you have to like talk about it, but then like keep up with that promise. For the business model, I guess it would be, you guys are the core maintainers. You guys sort of write all this code. And then if someone needs help with integrations, or where would sort of you guys profit from this business?
Yeah. So we don't want to position ourselves as like a consulting shop or like dev shop kind of on the side, and helping people like implement stuff with Commonware. The business is more predicated on the like Next.js for sell approach, where like they release Next.js and maintain it, but then they augment it with Vercel, and you would pay, or like basically the not the user, but the person launching the application would have a relationship with Vercel, in our case, with Commonware, to build out all these different things that they might need from an infrastructure side. Now, to be super clear, you don't need anything. You can build all your own stuff if you don't want to work with us at all. Like, there's nothing stopping you. Like, there's no alliance or something like that we're going to start up that, like, I don't know, like there's nothing like that. But if it's useful or helpful to like interact or leverage the stuff that we use, like, yeah, we would expect to form like a commercial relationship with anyone that is leveraging that. And then the idea there is that if you yourself as an application wanted to charge for some of the capability that we offered that you layered on top of or whatever, that's totally fine. Our relationship is with the application developer. It's not with the end user. So we're not trying to like do something like an Alchemy where we're charging someone to access some sort of API and like everyone has accounts with us. It's the other way. Like we work with the teams that are launching stuff, and if they want to give it away for free, great. If they want to charge on top of that, they can. The whole point is that we know that developers will need a lot of additional capabilities at high throughput that it would be very expensive or difficult to build on their own. We think that we can provide a really interesting mix of products that they would be interested in leveraging to maximize their speed to market, but they don't have to. So it's much more of an opt-in sort of thing.
Yeah, I think the Vercel example is great, because everyone knows that like it's just AWS but more expensive, but like it's so easy, so people just like, I'm just going to use them.
Yeah. Hopefully we have we come off better than AWS, but more expensive. I think, they're some of their shims are super thin, like the CDN one or like some of these things like that. I think there's like, at least in this space, because I think like one way to think about it is like AWS obviously is powering Amazon.com. a lot of people that are launching on Next.js are building websites. So like Vercel, there's a lot of stuff AWS offers that Vercel can just kind of redirect into Next.js. With crypto and blockchain, like AWS doesn't have a public blockchain. They don't have a lot of the capabilities that you would probably need to actually build some of this stuff. And so I expect the delta between like what is commonly available and like what Commonware can provide to be a lot larger. And again, if you want to build it yourself, you totally can, and I wholly expect some people will, and I also expect other vendors to come into the space to work with Commonware chains as well. I think that's a really healthy thing and should be applauded, because I think a lot of people launching on something, if there's only one way to run it, get terrified, right? Like that's an immediate red flag for a lot of different people, because you put so much trust in a single vendor or a single counterparty. And so we think that's a really good thing, and we think there's a lot of really cool stuff that we can build that really just makes it faster, and you can build cooler applications. That's really the goal. Yeah.
Yeah, I really liked Commonware just because it was like, it's just code that you can use. It's not like another ecosystem. There's not like a token. It's just like crypto at its core. Anyways, time to, I guess, wrap things up. Is there anything else you want to talk about? Call to action, builders you want to talk to?
Yeah. Appreciate again you having me on. Yeah, two things. We announced our first hire a few weeks ago, Brendan from DYDX, which I think a lot of people in the Cosmos ecosystem know pretty well. We're announcing our next hire on the 8th tomorrow. So I don't know when this will come out, but maybe it will be after that. So if you're interested in like collaborating with us on open Rust code and any of this sounds interesting, like would love to chat. Send me a message on Twitter. And then on the application developer side, if like any of this resonated with you and you just want to talk about like what you're trying to build, happy to spend the time, get to know you, get to understand, really what you're working towards. One awesome byproduct of spending 2 years or so at Coinbase working on Rosetta and like working with all these different people launching different things is I've gotten to know like a broader swath of like the space of like what people are working on and like why they're working on it or whatever. And sometimes for application developers, we may not be the right choice. That's fine. But I'm happy to help collaborate or chat with you on like kind of how to navigate what way to go. And if Commonware is useful at some point, great. If not, it's more crypto applications that are launching, which is awesome too. So happy to chat. But yeah, thanks again for having me. Glad to finally make this work. Yeah.
Anyways, thank you so much, Patrick.
Thanks.